Hey everyone. So there's a couple typical issues we run into when we're uploading large or complicated files to Mapbox. One is a zoom issue where features seem to disappear or the whole data set disappears after you zoom out to a certain point. And the other is just a problem with really large files that don't match the upload limit for Mapbox, especially when you're like drag and dropping in the file. So in this video, I'm going to go over both of those in a couple of scenarios. So the first part will just be like dealing with this zoom level issue and how you can upload using the Mapbox tiling service or MTS into Mapbox. And there's a little tool to help you do that. And the next section will be about splitting up a TIFF file that is 11 gigs in size and how to get that actually uploaded into Mapbox using all the command line kind of work that Mapbox has with their Uploads API and showing you another tool that Mapster's put together that can help you do that more easily. So enjoy the video. Hope it helps you out.
Hey, okay, we're in the tile sets section of Mapbox. Now what we're going to look at is what happens when you upload a data like a GeoJSON that's small enough to actually meet Mapbox's upload limits, so less than 300 megabytes per upload. But it still doesn't seem to show things at the right zoom levels. So let's identify the problem first. I'm just going to use this data from this eric.clst.org site, which is basically just all the US counties. So this is a data set that a lot of people use often for many different applications. And the reason I'm picking it is because there's enough counties that it's very, very detailed. And yeah, it'll actually suit our purposes here. So if I was to download that, I already have it downloaded here in a folder we'll be looking at a bit more later. But let's try just uploading it to Mapbox. So we'll just drag it in. It's about 22 megabytes, so it's far under the limits. Okay, so we're all completed here. Probably took like a minute or two. Now, if we load this in, we see this data looks great. It's all showing up. We're at zoom level 3 right now. So if we zoom out just a little bit, it all disappears. So that's fine. It's all there all the way up to whatever zoom level, but it's obviously a problem if our client for some reason wants our app to open, say, at like this kind of zoom level, or wants to make sure the counties are appearing. We're kind of screwed. That's not there. We can see we have our different data and everything, but what we're going to go over first is how to get this uploaded into Mapbox directly without running into this problem of the zoom level. So to do that, what we used to have to do was use something called Tippecanoe, which is from Mapbox. This was a little annoying because it only works on iOS or Linux. So if you're using Windows, it would just be a total non-starter, and you wouldn't basically be able to figure this out unless you use QGIS or like another whole application to convert your files and do all kinds of simplification on them. So this was great. It's got some really good docs here. You'll be able to make your way through it without too much trouble if you give it a try. You basically run Tippecanoe, you tell it the zoom levels, you give the file out, which is going to be an MB tiles file, and tell it the file that you're passing in, and there's some options for how you want to handle what it's going to do at the different zoom levels, and it'll pump out MB tiles. This still might be a good option as opposed to what we're going to do next, and the more modern way of doing this, if you're also trying to like condense your file or change the size of your file at the same time. MB tiles tend to be smaller and more efficient, and it stands for Mapbox tiles, so it's obviously like built for Mapbox. So Tippecanoe is as a good option as well if you prefer command line to do everything that we're going to look at, but there's actually a lot of options. So I wanted to bring up Tippecanoe first just to point out that this was the old way and still a good option. But the more modern thing that Mapbox has come out with, and it's still in beta, but it's been in beta for quite a long time now, and it's pretty well solid and established, is Mapbox Tiling Service, or MTS. So this is basically using API endpoints in order to build your tile set and send the features to Mapbox, and you can specify what they call a recipe, which basically tells all the sorts of things like what zoom levels you're going to have, and lots and lots of different details in the recipes. If we look at the recipe reference, we can tell it what zoom levels for different layers, and just lots of different stuff in order to tell it exactly where everything's going to appear. There's dig in this. You can even use Mapbox expressions, which it gets really, really complicated. We're not going to get into all that. We're just going to keep it simple today. But the core of it is that there's basically an API that you can send your data to, and it'll send it to Mapbox, and you'll get around all the issues with those zoom levels. So let's do that. So I've built a small script, which I will have a link to the GitHub. And this script is just a node script that basically takes in a GeoJSON, converts it into the format that we need in order to use the MTS, and then sends it to the appropriate endpoint. It's a very simple script, and feel free to use this and adapt it to your own needs. Basically, to walk through it real quickly, we get our GeoJSON. In this case, it's a GeoJSON. You could have different types of files that you're pulling from, obviously, and we output it as something called a line delimited GeoJSON. So that's more or less a GeoJSON where every feature is a line. It's just a GeoJSON, but instead of being inside like a feature collection like we're normally used to, every feature is just a line. You can see they're literally line delimited. There's no comma or anything. And this is, I don't know why they decided to use this. I guess maybe it's a little bit more standardized or something, reduces the file size slightly, whatever. I don't really know, but that's what you have to have it in. So I do a little bit of parsing in here. We join them with a line break, and then we run through the appropriate endpoint, sending the data in the right way as form data and all this stuff. So this can be used either to create the tile set or update it later if you've changed data. So if you have a client that has data that changes on a regular basis, you could use this script to run every day and it would update the tile set instead. Again, this is much easier than the old method of like using Tippecanoe and then having to hook it up to some kind of upload mechanism and all this stuff. So let's run through real quick actually using this script. So all I'm going to do is I'm going to head over to Mapster Teach, and I think I called this Big Data. Yes, and then we're in here, Mapbox MTS Upload, and we're just going to run node convert.js, and that will run this file. And you'll notice I'm actually on Windows, so I couldn't use Tippecanoe anyway. We get a couple notes like, okay, the tile set source has been created. It tells us about the size. It tells us that it did create the tile set and it published it. Now, if we head back to the actual Mapbox web interface, we're going to see our tile set here, and it's basically processing now, and that'll take a little while. So here it is. I've called it US counties, and we click in it. We're going to see, I actually already did do one before as prepping for this video, but deleted it, and now it's doing another one. Now here we can see the recipe I used, which is really just the default recipe. You can again look into these more. I basically made it that the min zoom will be 1 and the max zoom will be 10. We'll see about what this max zoom really does once it's loaded, and specify the source, which was also created during all this API stuff. So I do create just a very simple recipe here, but you could adapt that to your needs as you want. All right, so our processing has been completed. So we can see here we are now at zoom level 1, and this is all present. It's the same data set, no changes. You'll see as soon as I go under data level 1, it disappears, but that's just because the recipe says it starts at 1. So I could just set it to 0. It would be no problem. And it will just simplify it using its own algorithms. You can do all more in the recipe, telling it more details about what to drop if you don't want to drop certain types of features and that sort of thing. So as we zoom in, it's all here. Now, does it keep staying there after zoom level 10? It does, which is kind of strange. I don't totally understand why the recipe, when I put max zoom, it stays at 10, but it's still visible after level 10. I suspect that's maybe like the top zoom at which it will like keep checking, making more detail or that sort of thing. Somebody can post in the comments about that, but to me, I've really not found that to be a very important thing anyway. It's always easy to just make a layer invisible, but it's not very easy to make a layer visible when it's not rendering at a certain level. So I'm not really worried about that. Now, just to tack on a little bit more about what's important when you're simplifying data. When you zoom way out, it's okay to lose a lot of detail because no one can tell the tiny little features in these counties when you're way zoomed out. So you're going to lose a little bit of precision, but it's almost irrelevant. But depending on the different type of simplification that you use, you might be dropping whole shapes instead of just dropping points within shapes. So just keep an eye out and be aware that there are different ways to simplify data at different zoom levels in order to preserve that data. All right, so for the next section of this video, what we're going to work on is uploading a large TIFF file. What we're going to do is modify the TIFF file, do a bit of conversions on it, and ultimately upload it using a special CLI tool that we've created over at Mapster. So we're going to use this Moon TIFF. This USGS site, astrogeology.usgs.gov, has some really cool maps if you're into space stuff, if you're a space nerd like me. One of the reasons we're going to use this is because it's cool and also because it's very large. It's an 11 gigabyte TIFF that they give us. Now, in our Mapbox docs here, we have upload limits. So if you're handling anything bigger than 300 megabytes, you can't upload directly in the website. And the absolute limits are listed here for the different file types. So there's all these different ones, the largest being Mapbox tiles. So if you're doing MB tiles, that's a great format to convert things to. If you have a CSV that's like 12 gigabytes, maybe try converting it over to Mapbox tiles. Anyway, we're using a TIFF, a GeoTIFF, that's going to be 10 gigabytes maximum, and ours is already 11 when it comes in. Now, there's a couple different things we can do, and we're going to go through that and convert them. And ultimately, these also have to be uploaded using the data sets or the Mapbox API, which we're going to do through this CLI. So one of the things that we want to do with any TIFF file is we want to make sure it's a BigTIFF. Mapbox wrote this post many years ago when they started implementing using BigTIFF. Basically, to put it short, TIFF files generally, as far as I know, I'm not a super expert in this, but can't exceed 4 gigabytes in size, or else they kind of like are improperly formatted or something. So BigTIFF allows them to be larger than that. And it also compresses them quite considerably. So if you get a TIFF file, just a plain TIFF file from a client that's large, using BigTIFF, you'll probably make it quite a bit smaller. I believe that this TIFF file is already a BigTIFF. I don't really know. It says here, yes. So it uses BigTIFF. So we're already using BigTIFF in this file we get downloaded. So just running it isn't going to allow us to reduce the size of it in this case. So we're also going to have to split it. We're going to have to split it and then also make sure each piece that we're uploading is BigTIFF. So what we're going to use to do this is GDAL. GDAL translate in this case. GDAL is a whole geographic suite of command line systems. You can use it in programming, you can use it in Python, that sort of stuff. It's a whole thing to look into. I'll probably make a separate video on GDAL as a tool. I'm not going to go over it really deeply this time. In my Windows machine, I install this using OSGeo4W. It creates a whole shell that's separate from PowerShell or the command line prompt normally, and then I can use the various GDAL commands in this special shell. So we're going to be using GDAL translate, and we're going to use one other as well. So give this a look. So I already have this open. I've been doing a bit of testing, so this video will actually work. And what we're going to have to do, what I want to do is I want to split this file into two separate TIFFs, and then I'm going to upload each of them separately to Mapbox and then put them together on a map. That's just kind of my hacky way of doing this without losing anything of the TIFF quality. So the first thing I need to do is I need to run a GDAL info that's going to tell me how large this original file is. So I already have it in here. I've already split one as my test before the video. And this is the original file, this lunar, this large name, and it's 11 gigs here. So it's large. And when I run this GDAL info, it gives me a whole bunch of information. So it tells me this is mainly what I'm looking for. Size is, and it has these large numbers, and then it tells me a bunch about it tells me really good information for other things that you might want to do with your geographic files, projections, the origins, the coordinates, all these kinds of things like that. In this case, I'm just using this information, and what I'm going to do is I want to split the file basically into a left side and a right side. So I'm going to take the X coordinate and I'm going to make it half. the whole thing and take the whole y coordinate, and then in the next split, I'm going to take the other half and the whole y. So you can see I did that here, where I said, okay, GDAL translate, and I took this command from the Mapbox post, which is basically turning things into a BigTIFF. Now our file was already a BigTIFF, but this just makes sure it stays one. And I use this this flag here, source win. I don't actually know what that stands for, but it's the command to basically split you can tell it the tiles or the size that you want to take from the original TIFF, and it'll just take those ones and move them into your new file. So I took half of this value, this 184,000 was 921,000, and the whole y value, and put that into something called btlunar1.tiff. Okay, and it took a few minutes. Now I'm going to do the same command, but this time I'm going to, let's see, where does that command come up? There it is, btlunar2, and I'm going to make this start at 92,160 instead of start at 0. Here we have the offset and the X size. So hopefully if I just run it again like this, we'll get the second half of it just fine. Now this is just about finished. So if I'm not sure, which I'm actually not 100% sure if I split these up correctly, what I could do is open them in another program like QGIS or something like that and take a look to see, oh, are they split up right? In this case, I'm just going to roll with it because really this is just a demo and trying to teach you how you could do this sort of thing. Now looking at it, we have our btlunar1 and our btlunar2. You can see they are both smaller. Our main goal is to be under the Mapbox limit. So we are under the Mapbox limit now. So we're going to move on to using the CLI tool to actually upload these to Mapbox. So what we're using to upload these to Mapbox is the Mapster Upload CLI. So that's something we built over at Mapster because we were tired of walking through the step-by-step process that Mapbox has. We have the Mapbox Uploads API, which is here at Mapbox API Uploads. And there's this whole process you got to go through. You got to request S3 credentials from AWS, then you got to upload them, upload using a URL you retrieve. It's just this multi-step process that it's not the end of the world, but it's a bit of a pain to just have to do it over and over, or you screw up one step, it all kind of breaks. So we made a CLI tool that will just like package it all together into one tight, easy thing. So all you have to do is have a Mapbox account, obviously, and create an access token, a secret access token with certain permissions here. Then you just need to run npm install, npm start, and it will prompt you for various information. So we are going to pop open a new PowerShell window. And here we are. We can see our files listed there. And what we're going to do is we're going to run npm start, and it's going to ask us our username and Mapster Tech. And then we're going to have our token, pop that in there. And then we select the file we want to upload, BT. So we're going to call it btlunar1. And there we go. Now it'll just run its upload. So you can see I actually still got an issue here with my proposed upload exceeding a maximum allowed size. I don't totally understand why this is, but I have a feeling it has to do with some kind of like formatting unpacking of the original file. That's when it's TIFF, but Mapbox receives it and looks at it, it's still larger than it's expecting. So I've had this problem with TIFFs before, which is partly why I'm making this video. And I'm gonna try in this case to just keep splitting it up until I get to a size that is small enough that it actually allows it. So I've split it up again, like this original one. I've split it btlunar1 into one half as again, and we're going to try again to run npm start and see if we can upload that one. So it's now at 3 gigabytes, which is well within the Mapbox limits. Put that in, and we're going to select this TIFF file and call it btlunar1 again and see if this works. Okay, so that took a while. That probably took 20-30 minutes to upload, but it is done. You'll see here that once the upload starts, it'll say, I can't unfortunately scroll up higher because this went for so long, but it'll say something like file upload successful, upload beginning, and then it will do this upload. And it's just that there's multiple steps. This upload, I believe, is the one that's actually going from AWS, the S3 bucket, to Mapbox itself. So it's just going along, and it'll just ping and keep checking for this as it keeps going along, shoot an error to you if something happens, and in the end you may get lucky and you get upload complete, Mapbox Studio. So I just uploaded that 1/4 of it, remember, and it did upload successfully, and here it is. It's sitting there right in the middle, randomly put on the Earth because it is, of course, the lunar data set. You can see the quality is pretty decent as we zoom in. It looks really cool, actually. So if we come back out, and if I wanted to put that on a style, we can have some fun here. Obviously, we're messing around with all kinds of different planetary stuff. But I go to Layers, I add, I'm going to grab that source here from BT Lunar. There it is. It's a raster. We drop it on there, and it will be loaded. And as we turn, again, it's only 1/4, but that looks like it's correct, 1/4 of the total tile set. And yeah, if we just added the others and clipped them in. I was planning to add the others originally, but the upload took so long, I don't really want to bother. You can understand the overall process from what I've done here, and you get the idea. You split up the rasters as you need and use our CLI tool to upload them. And they're going to be up there in Mapbox, and now they're provided. So what have we gone over in this video? We've gone over uploading things using the Mapbox API in an actual node app that we've created. We've gone over splitting up some really big data when it comes to TIFs, which I think is one of the most complicated, and we've gone over using our Mapster Uploading CLI tool to really easily upload those large files. When it comes to other file types, there's so many things you can do. You can try simplifying the GeoJSONs using a tool like MapShaper or QGIS. You can convert files, and again, you can use GDAL to do this, from KMLs to MB tiles, from shapefiles to MB tiles, from probably even TIFs to MB tiles. You can go in all these different directions with converting. So whenever you're running into problems trying to get large files into Mapbox, come and stare at this for a while and think about, how can I get my data into one of the formats that preferably MB tiles, that is really allows a large file. And then once you get it into that place, try using the Mapbox Upload CLI to do it. As I said, the GeoTIFF, it is 10 gigabytes, but I think there's something funky that goes on with unpacking. But the others, I've never found there to be an issue. These seem to be accurate and fairly straightforward. So hopefully this whole video has helped you deal with large upload sizes in Mapbox, and please leave a comment if you need some more clarification or more help with that. Happy to help, and we'll see you next time.